Hi, in this tutorial we will see how to compute work needed to pump water or some other liquid out of a tank. Let's start with the following problem. In this problem we have a rectangular tank with certain dimensions and we want to find how much work is needed to pump the water out of this tank. And here we will go ahead and start with drawing a picture for the problem. We have a rectangular tank, so it roughly looks something like this. And this edge here is 10 meters, the depth is 2 meters, and it is 3 meters wide. So this is the tank we have. And we want to find the work needed to pump the whole water out of the tank. For these sorts of problems, the very first thing we have to do, we have to introduce the coordinate system. Since we will pump the water out of the tank in the vertical direction, I will introduce the vertical direction first. So here is the starting point, and this is positive, let's say, z-axis. And let's say the remaining two axes are down here, x and y. So the bottom of the tank is on the xy plane. Alright, so here is the origin, and we increase as we go up, and the top of the tank will be z equals 2, right? Okay, so how do we find the work needed? In this problem we will use the slicing idea. We will slice the tank and we will compute how much work is needed for that slice. So let's start with a slice. Since we are pumping in the vertical direction, I will slice the z-axis. Let's take a slice at level z. So level z means from origin up to that point is z much. And we are taking a slice here. What will be the width, what will be the height of this slice? It will be nothing but dz, right? So I want to compute how much work I need to pump this much water out of the tank. So how do I find work? Work will be, for this slice, mass times g times distance, right? But how do I find mass? Mass will be volume times density times g, and I have to multiply everything by the distance. So for this slice, I have to compute two things: volume of the slice and the distance, right? The other two quantities are known, namely g is a constant, and d is just 1 for this problem since we are looking at water. Alright, so let's go back here and let's try to compute the volume of this slice here. What do you think this slice is going to be? This slice is nothing but a rectangular box, right? So what will be the volume of the slice? I have to multiply 3 edges, right? So this edge here is still 10 meters, width is still 3 meters, but the now height is dz. So I have 10 times 3 times dz, which is 30z. 30 dz. Okay, what about the distance? How do I compute the distance? This is the distance, how much I will move this slice. So I want to take this slice out of the tank, so I need to take it from where it is to where? From where it is to top of the tank, right? So here, this will be the distance I have to move. Distance from this slice up to top of the tank. Remember, from the top of the tank to bottom is 2. And we said from bottom to up to the slice was z. So how much is left for this top part? It is nothing but 2 minus z. Okay, so the distance will be 2 minus z. Now, when I combine all these things, I can find how much work is needed for this slice. I need 30 dz times density, which is 1, times g, I will keep that as it is, and distance. What is distance? 2 minus z. Okay, this is how much work is needed for a slice, and to find the work for the entire tank, I have to integrate this expression from where to where? From the starting point, the smallest value for z is 2, and the largest value is the top of the tank, which is 2, right? So I have to compute this integral from 0 to 2. And it's not too hard to compute this integral. I can pull 30 outside. I have 30g. Then I have integral from 0 to 2. Then I have 2 minus z dz. And this integral will give me 2, so the answer will be 60g. Okay, alright. What about the second half of the problem? Remember, in the second half, we have only water to the half of the tank. So here is the tank. Remember, this edge was 10 meters. The width was 3 meters. And the height was 2 meters, right? But now we have water only from here to up there. So only half of the tank is full. So when I find the volume, when I find the work needed for this part, again I will do the slicing as I have done in the previous part. But now when I integrate, I will integrate from 0 to top of the water, right? And the water doesn't go all the way to the top. It stops at the half of the tank, which is 1 meter, right? So in this case, work needed will be integral from 0 to 1 of the same expression, which was 30g 2 minus z dz. And here this will be 30g times, I will integrate this expression, which will give me 2 minus 1 half, which is 3 halves, right? Which will be 90 over 2g, which is 45g. So let's go back to the previous answer. It was 60g, and half of the tank will require 45g. So it is, as you can see here, it is not half of the work, right? It is more than half of the work. And this makes sense, right? Because it will take more work to pump the bottom of the tank than the top of the tank, right? The top of the tank is closer to the pumping area, so I will move this piece less, but here the bottom is farther away, so I need to move it more. So here, to pump the bottom half, I have to do more work. For the top half, I will need less work. Okay, we will continue these kinds of problems on Tuesday in class. Okay, now let's look at the following from the web assignment. This is very similar to what we have discussed in the previous problem, but as you can see, instead of a rectangular tank, we have a sphere. So the geometry of the problem will be different. Now, first I'd like to start with again introducing a coordinate system. And again, as you see, we are pumping the water in the vertical direction. So for that reason, I will go ahead and introduce a vertical direction first. So let's say this bottom of the tank, let's call it the starting point, and let's move in the positive direction. Let's move in the positive direction, and let's call this axis here, again, the z-axis. So here's 0. I will move up to here will be the radius, which is 9. Up to here will be the diameter, which is 9 plus 9, 18, and plus this height, which is in my case nothing but 3 meters. Alright, again I can say the rest of the axes are here, x and y. But as you can see, I will mostly need the z direction. Again, we will go ahead and do slicing. So we will go ahead and take a slice on the z-axis, let's say somewhere here, right? And I will look at how much work is needed to pump this slice out. Okay, here's point z, and the height of this slice will be dz. Okay, so let's start with the slice. What do you think the slice is? As you can imagine, this slice will be a disc, right? It will be a disc of something like this. Will be a disc like this, and the height will be nothing but dz. Okay, so how much work is needed to move this slice? It will be volume of this slice times the density, times the density of the liquid times gravitational constant g times the distance, right? So unlike the previous problem, the density will be different. I have to compute the volume, g is a constant, and I have to compute the distance. So let's see how this works. Now let's go back to the slice. Remember, the slice was this, so when I compute the volume of the slice, I have to compute the volume of this disc. This is like a cylinder, right? So the volume will be pi times radius square dz. So the problem here is finding this radius here. Let's go back to the picture. Here I'm looking at the slice at level z, and I'm interested in this radius here. Okay, how do I find this radius? That's the crucial problem. Okay, how do I find this radius? Let me go ahead and choose another color. And my goal is to find this radius here, right? Okay, so what happens when I connect this point to the center? This edge will be the radius, right? It will be as much as the radius, which is in this case 9. Then here, what about this edge here? It is nothing but 9 minus z, right? So I have here the radius, and here I have a right triangle, which has 9 minus z, 9, and the rest of it. So I'm looking at this part radius, so that will be nothing but 9 square minus 9 minus z square in the square root, okay? So here I will get, inside here I will get square root of the quantity 9 square minus 9 minus z quantity square. Okay, what will be this expression? Pi will stay there, this 2 will cancel the square root, and here I have 9 square minus 9 minus z, which is nothing but z times 18 minus z times dz. Okay, so this is volume of that slice, which is one of the important parts of the problem. Next comes the distance, how much we will move this slice up to the pumping opening here, the stroud. So let's look at the distance. Here I have to move this slice from starting from here all the way to here, right? So here I have the height h, which is 3 in my case, and then the rest of the distance from here to the top of the thing. Remember, from bottom to the top was 18, right? That's the diameter. But I'm looking at the slice at level z, so here I have to subtract this part, z, and that will give me 18 minus z, right? So the distance that I'll have to move this slice will be 3, that's the height, plus 18 minus z, which is 21 minus z. So now I can write how much work I need to move this slice out of the tank. Remember, it will be volume, and the volume was pi times z times 18 minus z. 18 minus z times z times pi, right? Then becomes the density. In this problem, what's the density given to me? I'm told it is 900, so I have to multiply the volume with the density, which is 900, times the gravitational constant g. I will keep it as it is. Then I have what? Distance, right? And we notice that the distance is 21 minus z dz, right? Okay, so this is how much work is needed for a slice. How do I find the total work? I have to integrate this expression, right? Let's go back and look at the integration range. Z changes from 0 down here to top of the tank, right? So it goes up to the diameter. So this integration will be from 0 to 18. Okay, now I have some constants that I can pull out, so let me do that. I can pull 900, I can pull pi, and I can pull g, right? When I do that, I have integrals from 0 to 18 of this expression, z times 18 minus z times 2 minus z dz. oh sorry, it's not 2, right? It is 21 minus c. So it is 21 minus c. Sorry. Okay, so I have to compute this integral. Now, how do you compute this integral? I would suggest you to multiply this part, so you get z times 18 times 21 minus 21z minus 18z, which will give you 39z plus z squared. Now distribute the z over, then integrate, and you will get the final answer somewhere here. So I want to assign this final answer to you as an extra credit. Please go over this problem, write everything out by yourself, then compute this integral down here, find the final answer, and give me give me your solution, give me your final answer at the end of class on Tuesday, and you will get, if you do that, I'll give you some extra credit points. Okay? Alright.